Alright, Mr. West here. On to the fuselage, the PVC, 4-inch PVC drain pipe fuselage fabrication. A little bit about that. So what we're looking at here is with the wing off, and with a wing, this may not fit. No, it doesn't. My sample is a little bit bigger than the space available here, so that means that this is a little bit bigger, obviously. But the point is that it sits in there like that, and there is a hold down in the front, like so. There's no mechanical; it's simply structural that holds it. The mechanical part is here in the back with 2 through bolts or screws into the wing hold down blocks right here. Wing hold down block. All I did is drill a hole and screw gun drive those machine screws in, making their own tap. And the thickness of 2 layers, 3 layers in total, so about an inch, not an inch, excuse me, about a ½ inch plus 5/8-ish thick of threading going on there for the grab. So what is this made out of? The that plywood I spoke of earlier, the import plywood, the handy panel material that you can get at Home Depot for the 1/4-inch stuff here, front and back, a little beefier. And then the sides is a 1/8 3/16. Certainly you could have done it out of this. I had some of this material here, and it is a maple veneer. The toe kick material that is supplied with kitchen cabinets often is a plywood, and it's lightweight and works pretty well. It's pretty strong. But a lot of times it's the MDF with the veneer, wood veneer over it. MDF is very heavy and has no lateral strength, if you will. Unlike the plywoods, you can try to bend it like in a spar. The tension against it is across the plane as opposed to this way with the plane. Not the airplane, but the plane, the surface. Alright, so essentially what we've got here is a saddle that drops down into a notch. So again, a chop saw cut down into the plastic, front and back. This of course is all added on later. So just imagine this portion right here on up to here and across. So the width of the outside of this tube is like 4 1/8, 4 1/4 on the outside, and the hold down assembly, the saddle assembly here, is 4 inches wide. It could have been exactly the same, it would not matter, but I thought that it planing out short of the exact width would have been okay. There's plenty of a lot of grab here, a lot of strength to handle that wing. So this is a rectangular, just a rectangular piece, right? And let me grab another sample over here. This is PVC, 4-inch PVC 1, version 1. So you can see that this piece, which is a little bit different on the V2, it's just a block that runs straight across. And there was another one on the front here that runs straight across, and you cut into the PVC, allowing for this block to slip down in between to make this width right here. And I'm using the chop saw just basically like this, dropping down in. You've made side cuts here, this side cut on both sides. There's a line for it right there and another one on the other side. After you determine a center line, then run a side cut on the table saw. That can be a little tricky. excuse me. So you're lining it up basically near center, and you mark the inside of the pipe. Mark the inside of the pipe where you're going to make your cut. So essentially you're holding it down like this on top of the table saw to get that cut on the inside right there. And with some knowledge, skill, and previous experience, you can do it that way. This is the way I do it on the table saw. Certainly you can mark it out by hand. You can take a Dremel and cut by hand, because that line and that cut right there is not critical in the slightest. It's just an opening. And you want it as wide as possible, right? Because you don't need any more plastic right here in your way. You want it all the way out to, just so that you have a good glue point out here for the saddle assembly. Hopefully that explains it. I'm using 5-minute epoxy on all of the glue joints in the wood-to-wood connections. Epoxy does not work well against this plastic. It just pops right off. And in the V1 I used epoxy, not realizing this, and it'll pop right off of here if I give it enough energy. What works really well is hot glue. So what's down here in the bottom? This is the landing gear for an aluminum landing gear, or it could be a wire landing gear block or anchor point. And I've added some material on here to get this buildup. Normally it would be down flush. I added this extra in here after the fact, as one layer of that plywood right there wasn't enough to hold the screws proper. It's a lightweight. It's that import plywood, not ideal for screws and taking that kind of pressure from landing. So how did I get these curves? You can stack this on top of a piece of wood and trace it on the inside, which is what I did, and then cut by hand. I have a belt sander that I use to shape. I lay it up horizontally on the table, clamp it down, and I'll use a belt sander to do shapes and so forth. So these were shaped in by hand. Here, those two connecting blocks down here that creates the front and back formers. Alright, and then the landing gear just lays right in there and a couple of screws, good to go. So back to the V2, you can see that same block right back in there, and I'm using a plywood that has a cherry finish on it. You can see it right here as well. Let's look up underneath. That's like that. And I ran it up in there that far because the width of that flat there that connects to the fuselage determined how far up I wanted to go with it, so that I can get all 4 screws into a block. If I made it more shallow, the cut more shallow, then those 2 outside screws would have been right in the edge or not even usable. So you fabricate your landing gear the way you want to do that. In fact, this could be just a single slot and use a wire style landing gear, which is a viable choice, but when you start getting heavier, the wire may not be enough spring to hold up the weight. So I stayed with an aluminum, a medium weight aluminum gear I had laying around. Okay, so hot glue. Hot glue is your friend. I used it all around. I used it here. Made some connecting points on the inside on both sides. Squeezed it all up underneath here, under these blocks. I epoxied. Oh, pardon me. I epoxied some squaring blocks. When I made this one, I basically did it on the table in the house. Got my parts all cut. Did the epoxy joining, putting these squaring blocks inside to bring rigidity to the whole frame, front and back. I made this profile based upon the cardboard template that I made on paper, which is somewhere. Where'd it go? Anyway, so remember the cardboard template that I made? You can make another one. And I used the cardboard template to shape out the saddle for the wings. Okay. This fill-in block up here came later after the wing was then fitted and done, covered, fitted, done, and then I took to the table saw and cut this angle to do this fill-in as a hold down in the nose. This cap then went on over the top of this foam filler block, and I call that the communication tower, comm tower, because on top of it there's communication going on, right? Antenna, blah blah blah. Anyway, some people who are mariners have some lake or ocean experience, might call that a wheelhouse. Anyway, it kind of looks like a boat. The hold on just a second. So once all this is attached and it's set level, parallel, this plane right here, the flat bottom of the wing, is set parallel to the tube. There's no degree of incidence, negative or positive, set into this fuselage. And in addition, the booms and the tail section have no degree, 0 degree of incidence installed on purpose anyway into them. I haven't actually seen a need for it. The flat bottom wings, in my opinion, that I have made, have never needed any degree of incidence. Could they have performed better with some? Maybe. I don't know. Couldn't really tell. The only way to know that really is in a wind tunnel situation. Some of the birds that I have seen, like the which one is it? The Hobby King's FPV EPP unit. That's that foam. It was kind of an inexpensive kit, bigger one, but it's in fact I have it. The my point I'm getting to, this bird right here, Hobby King's EPP FPV. Yeah, that's a mouthful right there. So it has a tendency to fly around with its tail down, like it's dragging its tail. So in this case, you would want to have a few degrees of incidence. That would bring the tail up. So that means the leading edge of the wing would be slightly higher and the trailing edge would be lower. So it creates an angle, a natural angle of attack. The wing is pointing up slightly, which makes the tail point down if they're on the same plane. Make sense? So building in a few degrees of incidence up in the leading edge of a wing is not necessarily a bad thing, but I've never noticed that my planes fly around with their tail down. I'm not really sure why. This EPP FPV is a flat bottom wing. In fact, it was designed originally as a flat wing, no dihedral. But I modified mine to have a dihedral in it, and then I glassed it. I put in wood spars and took out the stupid carbon fiber spars that everyone was having trouble with. They're square carbon fiber with round carbon fiber rod that slips inside of it, and they're always breaking on the ends. I usually never make my wings two-piece. It's kind of weak, and especially if you're going to load it up, it doesn't make sense to make two-piece. You're just asking for trouble on folding up your wings. Make them one piece. Usually a wing will fit in a car or a truck, no problem. It's when it's all attached as one, of course, that doesn't work too well. So anyway, my point is, no degree of incidence was intended or built into this project, and it flies around level. I have to, well, never mind, enough about that. So more or less you're just cutting a rectangular hole in the top of the fuselage, and you're inserting this whole assembly down into a chopped in rectangular hole in the top of the fuselage. Make sense? Pretty simple. Hot glue on all surfaces, hot glue on the inside, da-da-da. The motor block is a separate deal right there. The motor block is, I believe it's a 2.5-inch hole saw plug from a piece of plywood. So you can see it's round, right there. It's a round plug from a hole saw cut, 2.5, because it fits that motor mount precisely. And then what I did in this case is I just went ahead and hot glued that single plate to the back of the wing saddle assembly, and then I braced up underneath here from the motor at the bottom end here, as it's kind of flying, right? I braced from here to the landing gear attachment blocks inside to kind of to brace all that so it doesn't vibrate. I had thought real hard about bringing that motor up. Its position might be in kind of a turbulent, well, definitely it's in a turbulent place. It's kind of a dead air spot, because this fuselage creates a dead space, a dead air, or a place for air to get trapped and confused, if you will, not flowing. That's the idea. It's not flowing like it could. Say for instance with a with your high-mounted Easy Star and all that configuration, is the motor for the most part is all up in air, free-flowing air. So it's pretty efficient. This may not be as efficient. Therefore, mounting it up higher so it's just above the wing would have been a good idea too. And I still can do that with some modifications. I could simply remove this and go attach directly to the back end here and put a plate, maybe round it off on the top side right here, and mount the motor up here, up in the free air. Much better air and probably greater performance. It might be something I should try. The fuselage is not bulkheaded off in any way. There's no stiffeners. You can see right through the front to the back. There aren't any bulkheads in there to speak of. Does it need it? Maybe. Maybe not. Hasn't been a problem. If anywhere to do it, well, my design prohibits doing any bulkheads in the front area. The only place I could add would be back here, and it's unnecessary because it's already, all of this back here is braced. So there's no room for flex back here. Flex is happening up here in the front, but most of that is eliminated by this design. So I put a slip, or sleeve rather, taking a piece of the PVC, chopping it off on the chop saw, splitting it, reducing some by removing some out of the ring, fitting it inside until it fits perfectly, and then this is PVC, so I use PVC glue to attach from here to this one, clean up this line and this joint, and there you go. You have a sleeve that fits inside perfectly, or adequately, let's put it that way, inside this fuselage. See if I can do this one-handed. Yeah, I got it in my mouth. The mounting base that goes to the tripod sticks out like a tab. I was able to grab it. The hole in the top is to view the camera LCD of the Sony, the Bloggy, because it faces up when you lay it on its back and have it in position. So I just use a single screw here, and that seems to be adequate for, there's no twist or side to side or even up and down going on there. There's enough grab there to straighten it all out. Alright, so enough about that, I think. Post any questions, comments. That's how I attach. The wing has two locator plates that fit in between here, so keep that in mind if you're going to do this, that you want to leave space for a locator block to sit down inside that's attached to the wing. That way the wing is always set into the same position. I have one here in the rear as well. In fact, the locator block makes contact with this surface, so it's a sandwich between the locator block on the wing and here, and then the top bolts. There's a plate on top, a reinforcing plate on top that takes the load out of the pinch. When I run those screws down in, it's not pinching a small area. It's pinching right up against this block, so it's supported 100%, which I thought was a real good idea. Anyway, enough about that. Post your comments. May have some more information for you a little later. West out.